All right, guys, so today we're going to talk about absolute value equations and inequalities. We're going to solve those, remember how to solve them, etc. So I'd like for you to take a minute with your partner and talk about how to write these two graphs down here using interval notation. And so I want you to think about where you use brackets, where you use parentheses, what happens if there's a gap in the graph. So take just a minute and talk about that with your partner. Okay, take about 10 seconds and wrap up your discussions and make sure you have an answer for what's shaded. Okay, so here's what I wanted you to remember, and I hope that this is what you have with your partner. When we have a closed dot on our interval, okay, a closed dot, that's not a good arrow. A closed dot is a bracket. So we have bracket -2, comma, all the way to 5, parentheses because it is an open dot there. And then when we move to number 2, notice that our shade extends through our arrows. So we have to go from -infinity all the way to -3, parentheses because it's open dot, union. We skip over the section between -3 and 1, but we pick back up at 1 with a closed dot all the way to infinity. So I hope you remember that from Algebra 1, or from Algebra 1 and 2. We've done it in 1 and 2. And think about when we start graphing these absolute value inequalities, what our final solution is going to look like. So first, let's talk about absolute value equations. The first thing that we're going to do, these steps, and they're on your notes, is you're going to isolate the chunk. And by the chunk, I mean you are going to get the absolute value by itself on one side of the equation, completely by itself. No numbers in front of it, no numbers behind it, just the absolute value. Now, graph the absolute value statement. Here's what I want you to think about, is I want you to think about a question. A question to ask yourself is, where the solutions are located, okay? And that'll make more sense when we do one down here, okay? So where the solutions are located. We are going to make equations to fit that question, the answer to that question, and then we are going to solve for the variable. So let's look at example number 1. Example number 1 says absolute value of x minus 10 equals 13. So here's what we want to, first step, isolate the chunk. Okay, well, our absolute value is already by itself. Okay, so our second step is to think about the question, where are the solutions located? So where are the two places that we are 13 units from 0? Okay, so I know the one that immediately comes to mind is x minus 10 equals 13. Okay, we are 13 units from 0. The other one is -13. And so most of the time you're going to see me write that one first, just because I like to write them in order that they appear on the number line. And that is a negative that doesn't want to show up right there, -13. Okay, once we've done this is easy. We just solve. Okay, we just solve. So on our first equation, we are going to add 10 to both sides, plus 10 plus 10. Gives me x equals -3. Okay, then we are going to plus 10 on the other side, plus 10 on the other side, and I get x equals 23. Most absolute value equations are going to have two solutions because there are two spots where they are so many units from 0. Okay, I'm going to jumpstart you on 2 and 3, but then I would like for you to try those with your partner. So on number 2, is our absolute value isolated? I hope that you are saying no. So what we have to do first is divide by that 3. So go ahead and divide by that 3, and then I want you to see if you can do 3 with your partner. And I'm going to give you about 2 minutes to work on that. So go. All right, so let's look at our solutions we have going on here, or what we did. So in our first equation, we should have divided by 3 on both sides. So our first step looks like absolute value 2x plus 1 equals 2. Now I have the absolute value isolated. I can split into 2 equations. I have 2x plus 2 equals negative 2. 2x plus 1, excuse me, I read that wrong. Wrote it right. 2x plus 1 equals positive 2. Then we're just going to solve. So minus 1 minus 1. 2x equals negative 3. So x equals negative 3 over 2. My other equation, minus 1 minus 1, 2x equals 1. So x is 1/2. Okay, so again, 2 solutions, negative 3 over 2, negative 1/2. Okay, all right, let's do the other one over here because we got a couple of steps before we can actually separate it into our 2 equations. Okay, so first step is minus 1 minus 1. So 1/4 absolute value x minus 6 equals 7. Okay, now we've talked about this a couple of times in class. The much easier thing to do instead of dividing by fractions is to multiply by the fraction. Now what that does is it cancels this 4 and 1/4. So I get absolute value x minus 6 equals 4 times 7 is 28. Now I have an absolute value isolated and I can split into 2 parts. So x minus 6 equals negative 28. X minus 6 equals positive 28. Then I just need to add 6 to both sides. So x is negative 22. And then add 6 to both sides. So x is 34. Okay. All right. So I hope we remember this from Algebra 1, really, and then Algebra 2. Okay, so let's look at a couple of special cases. Some special cases, things where weird things happen. Okay, so here's our special cases. Okay, if you see these, it ought to be a big, let me make that red, a big red flag.